Hello everyone, this is our exercise 3 presentation for Dick's Sporting Goods for group 5. And so for the first exercise, we're going to look at data quality factors. And then so those two factors contributing to poor data quality are completeness and timeliness. And the questions for each that we need to ask is, for completeness, does it meet expectations of comprehensiveness? And then for timeliness is, what info is available when expected and needed? And so for the completeness quality factor example, so as we can see, this chart directly from the Dick's Sporting Goods playbook provides an example of how a lack of completeness can result in poor data quality. As specified in the second paragraph, the data set was incomplete as a portion of the water and waste data from 2016 was missing. This resulted in GHG emissions results being inaccurate for the year 2016. So this goes back to what we talked about, how a complete data set can either skew or accurately define a table or data. And then how would we measure completeness? And seeing the amount of data that is gained from each Dick's Sporting Goods. By doing this, we are able to obtain the most amount of data we can for each store and warehouse, and double checking and clarifying the data that is submitted. Some stores may not include certain stats or operations that may fluctuate the actual totals and percentages of waste for that specific store. So a thing to combat this would be having specific people getting hired for this job, as they will be relied to give accurate and complete data sets for the tables. And then so improvement plan for completeness, making a foolproof sheet that describes exactly what totals and percentages the stores are required to fill out, having a supervisor specifically make sure that the data being given is accurate and not skewed in any way. And then so for timeliness, many data sets are delayed due to the volume of data being collected and reliance upon external open sources. And then, for example, the data set from the EPA only runs through 2018, with that year being the most recent information available. This would factor into Dick's Sporting Goods' inability to collect some data points when running their analysis of GHG emissions in comparison with national data. So timeliness can be measured by reporting year to determine the lag in external reporting practices from primary data providers. When comparing company data to national data, there will be a longer period of time for external measures than internal measures. And so an improvement plan to combat this is a reasonable time frame set for data collection between various sources will aid in analysis expectations. Internally, information may be more readily available, and framing report times within the context of available external sources will provide more successful and realistic results. And so we're going to look at data characteristics and distribution. So as we can see with the data profile and data types, the varchar in this is categorical data. It refers to a mixed length character string, and double is a base SAS numeric data type. It is a continuous data, and SAS double refers to a 64-bit double precision floating point number. And so the varchar is classified further to detail that is in the string data. So as we can see, the missing data, not all of the data is given for the years leading up to 2018. So as we can see, starting at 1960, it goes century to century, or decade to decade, to 2010, and then it starts to go from year to year from 2010 to 2018. As we talked about earlier, the data set only goes to 2018, so we're not up to date on the materials generated. And so for data contribution, when viewing the data using the profile tab, no pattern is detected except for the materials, which displays a numeric value of 16. Thank you.